Solving Systems of Linear Equations Part 2. Solve the system by the method of your choice. Here we have two equations, two linear equations, and we can either solve this by substitution or the addition method. I'm going to solve this using the addition method. First, I want to rewrite the top equation so that all the letters are on the left side and then the constant terms are on the right side. So that just means that I'm going to subtract the y from both sides. So I get 4x minus y equals a negative 7. Now both equations are written in the correct form. So I can go ahead and use my addition method. Now I want to multiply an equation by a value so that when I add the equations together, the x's go away or the y's go away. If I multiply the second equation by a negative 1, when I add the x's together, they will be eliminated. So I'm going to multiply this second equation by a negative 1. And this gives me a negative 4x plus y equals a negative 2. And remember, I multiplied every single term by a negative 1. The top equation stays the same. And now we can add the equations together. When we do that, we get 4x minus 4x, which is 0, but then I also have minus y plus y, which is also 0. So both of my variables disappeared, and I'm left with 0 equals negative 7 plus negative 2, which is a negative 9. Now 0 equals negative 9 is not a true statement. So since 0 equals negative 9 is not true, the solution is no solution. And we can say that the solution set is the empty set. Solve the system by the method of your choice. Here we have two systems of linear equations, and I'm going to solve this system using the substitution method. That's because the top equation is already solved for x. So I can just go ahead and plug in my expression for x into the second equation. So I'll take the second equation and I'm going to substitute a 4y plus 1 for x. And now I'm going to solve this equation. The first step is to distribute the 3 to both terms within parentheses. We have 12y plus 3, and then minus 12y equals 3. I'll combine like terms on the left side, so I have a positive 12y and a negative 12y. So these cancel because 12y minus 12y is 0. So I'm just left with a 3 on the left side and a 3 on the right side. Now 3 equals 3 is a true statement. So that means that my solution is infinitely many solutions. That's the answer to my problem. And if we were to graph this system of equations, we would see that these two equations are actually the same line. So that's why there are infinitely many solutions.